Welcome to Service Vedic Academy. Today we are going to see what is prime number and what is composite number. Next, what is our main idea here is we are going to collect prime numbers from 1 to 100. Okay, so we can see what is prime number now. When we factorize any number, when we get 1 and itself as the factors, or any number which is divisible by 1 and itself, we can say that it is a prime number. So what is our prime idea is we have to find the divisors or factors of a particular number. Any number which has divisors other than 1 and itself, so it is not a prime number, we can say that it is a composite number. Our prime idea is going to collect prime numbers from 1 to 100. So we can, it's a very important thing we have to notice. 1 is neither prime or nor composite, because 1 is not belonging to prime number list or composite number list. So when we collecting prime numbers, we can eliminate this 1. When we check from numbers from 1 to 10, we can easily see that 2, 3, 5, 7 are prime numbers. Why? Because 2, the factors are 1 and 2, 3, the factors are 1 and 3, 5, the factors are 1 and 5, and 7, the factors are 1 and 7. So these 4 numbers are prime numbers. Other than this means we can see that 4 can be factorized into 2 times 2 other than 1 and itself, so it is a composite number. Likewise 6, it is 2 times 3. Likewise 8, it is 2 times 4. Likewise 9, it is 3 times 3, and likewise 10, it is 2 times 5. So we have collected prime numbers from 1 to 10, which is nothing but 2, 3, 5 and 7. So how many prime numbers are between 1 and 10 means it is 4 prime numbers. So when we go for bigger numbers, I have framed 4 steps which is easy to collect prime numbers. First step, we have to find 2 divisors, 5 divisors and 3 divisors. For this, we can see the divisibility rule of 2, 5 and 3. Here is the divisibility rule. When we check for 2 divisors, we can say that the last digit must be even number. When we check for 5 divisors, the last digit must be 0 or 5. When we check for the divisors of 3, we have to find the sum of the digits. The sum of the digits, if it is divisible by 3, we can say that it has divisors 3. So if we eliminate all the 2 divisors, 5 divisors and 3 divisors except 2, 3 and 5 means we can collect the remaining numbers or prime numbers. At a stretch, we can check the 2 divisors. So we have to eliminate all the even numbers. See here, we can, if we eliminate all the even numbers, we can eliminate nearly 50% of the numbers. Then what is the next step? We have to eliminate all the numbers ending with 5. So we have to eliminate all the numbers ending with 5 to avoid the divisors of 5. Then we can find the sum of the digits for the remaining numbers to eliminate the multiples of 3. See here, we can see at a stretch 1 plus 1, which is 2. 2 is not a multiple of 3, so we can say that it is a prime number. 1 plus 3, which is 4, which is not a multiple of 3, we can say it is a prime number. Likewise 17 is a prime number, 19 is a prime number. Here all we have to check the sum of the digits. So see here, 2 plus 1, which is nothing but 2 plus 1 is 3, which is a multiple of 3, so we can eliminate, this is a composite number. 2 plus 3, which is 5, which is a prime number. 2 plus 7, which is 9, which is a multiple of 3, so it is a composite number. 2 plus 9, which is a 11, which is a prime number, which is not a multiple of 3. We have to notice after this, we have to check the step 4 also. Here, what is the main idea? check the number for prime divisors. You can check the prime divisors only. What is the basic rule means? You have to check the prime divisors of the number, root of the number. Okay, this is the basic idea in mathematics. Here what number you have to check? We have to find the prime numbers up to 100. So if it is root 100 means we can take that it is root 100 is 10. So we can check the prime divisors which is less than 10. So what are all the prime divisors less than 10? 2, 3, 5 and 7. So already we have steps for this 2, 3 and 5 prime divisors. So if we check the remaining 7 divisors, we can get the prime numbers up to 100. Okay, let me check this number which is 3 plus 1, which is sum of the digit is 4, which is not a multiple of 3, so we can say that it is a prime number. 3 plus 3 which is 6, which is not a prime number. 3 plus 7 which is 10, which is a prime number. Then 3 plus 9 which is 12, which is not a prime number. Again 4 plus 1 which is 5, which is not a prime number. Here 43, 4 plus 3 which is 7, which is not a multiple of 3, so we can say that it is a prime number. Likewise 47 is a prime number. But when we go for 49, which is a multiple of 7 times 7, so which is a composite number. Here the 7 table we have to notice, the 7 table. Then we can check for the sum of the digits. 51 which is not a prime number, 53 is a prime number, and 57 which is not a prime number, 59 is a prime number, 61 is a prime number, 63, 6 plus 3 which is 9, which is not a prime number, 67 is a prime number, 69 which is not a prime number, 71 is a prime number, 73 is a prime number, 77 which is a multiple of 7, so we can eliminate this is a composite number. 79 is a prime number, 81 we can eliminate, 83 is a prime number, and 87 we can eliminate. Why? Because 8 plus 7 is 15, which is a multiple of 3. 89 is a prime number. When we go for 91, it's a crucial number. So with 9 plus 1 is 10, which is not a multiple of 3, but we can say that 91 is a multiple of 7. How can we check? 91 minus 70, which is 21. Why we are subtracting 70 means it is a multiple of 7. So the remaining thing 21, which is a multiple of 7, we can eliminate. This is not a prime number, we can eliminate as a composite number. 93 is also not a prime number because 9 plus 3 is 12, which is a composite number. Then we can go for 97, which is a prime number. Why? Because it is not a multiple of 7 and the sum of the digits is also not a multiple of 3. So we can eliminate 9 plus 9, which is not a prime number. Likewise, if we count all the numbers up to 100 means we can get 25 prime numbers. Students, you can do it by yourself and you can find the prime numbers up to 100 easily with this technique. Thank you for watching my video.